Hey everyone, and welcome back to Talk Tensors. Today we're going to be diving into a paper that really caught my eye. It's called Rate-In, Information-Driven Adaptive Dropout Rates for Improved Inference Time Uncertainty Estimation.
Sounds like a mouthful.
It is a bit,
Yeah.
but the idea behind it is really cool. It's all about making AI more honest about what it doesn't know.
You hit the nail on the head there. This paper tackles a really crucial problem in deep learning, which is how do we get our AI systems to tell us not just what they think the answer is, but also how sure they are about that answer?
Right, because blind confidence from an AI, especially in fields like medicine, that can be kind of scary.
Absolutely. A wrong call there could have huge consequences.
Exactly. So that's where this rate-in thing comes in, right?
Right. Raiden basically aims to make those AI black boxes a little more transparent about their uncertainty.
So less like a know-it-all AI and more like, hey, I'm pretty sure this is it, but here's where I'm a bit shaky.
Yeah.
Double check this part.
Precisely. And the way they do this is fascinating. Raiden uses this clever technique of dynamically adjusting something called dropout rates while the AI is making predictions.
Okay, now you've got me intrigued, but before we get into all the nitty-gritty details of how rate-in works, can you give us a little bit of context? Like, why is this whole idea of uncertainty estimation such a big deal in AI right now?
Well, traditional deep neural networks, as powerful as they are, they have this tendency to be overconfident.
Oh yeah, they're great at giving you an answer, but not so great at showing their work.
Uh-huh. Yeah, that's one way to put it. And that's a big problem, especially in those high stakes situations we were talking about. Like, imagine an AI that diagnoses a patient with a serious illness, but doesn't give the doctor any indication of how certain it is about that diagnosis.
That's not a good situation.
No, not at all. We need AI that can flag its own uncertainties, especially when those uncertainties could have serious consequences.
The authors of the paper use a really vivid example about prostate segmentation in MRI scans.
Oh, yeah, that's a great one. So imagine a doctor is trying to pinpoint the exact location of the prostate in an MRI scan. A traditional AI might highlight a huge blurry area as potentially problematic.
Which doesn't help the doctor very much.
No, it leaves them overwhelmed and unsure where to focus. But with Raiden, the AI could pinpoint the specific spots where it's less confident, allowing the doctor to zero in on those areas.
So it's not just about knowing that the AI is uncertain, but also knowing where it's uncertain.
Precisely, and that kind of precision is incredibly valuable, especially in medicine, where decisions need to be based on the most accurate information possible.
Makes sense. So before Radin came along, how were researchers even approaching this problem of estimating uncertainty in AI?
Well, one of the most common methods is called Monte Carlo dropout, or MCD for short.
Okay, MCD, what's that all about?
It's a pretty intuitive idea, actually.
Yep.
Imagine you have your AI model and you want to know how sure it is about its prediction.
Right.
With MCD, you run the same input through the model multiple times. But each time you randomly drop out, some of the artificial neurons essentially turning them off for that run.
So it's like asking the AI the same question over and over again, but slightly messing with its brain each time.
Uh-huh. That's a great way to think about it. And by looking at how much the AI's answers vary across those different runs, you get a sense of how certain it is.
So if it gives you basically the same answer every time, even with some neurons dropped out, you could be more confident that it's on the right track.
Exactly. But if it's all over the map, then, it's not so sure.
Okay, that makes sense. So this MCD method, has it been effective?
Yeah, it's been pretty effective, but it has a limitation. Traditionally, it uses fixed dropout rates, meaning the same percentage of neurons are dropped out each time, regardless of the input.
Ah, so that's where Radin comes in with its dynamic dropout rates.
Bingo! Radin's big idea is to adjust those dropout rates on the fly based on the specific input that the AI is analyzing.
So it's like the AI is thinking, this one looks tricky. Better be extra careful here and drop out more neurons to see how my predictions change.
Exactly. It's all about making the AI more adaptive and responsive to the challenges of the specific problem it's facing.
I can already see how this could lead to some much more reliable AI predictions, especially in those high-stakes scenarios we've been talking about. But how does the AI actually know how much to adjust the dropout rate? Like, how does it find that sweet spot between being accurate and being appropriately uncertain?
That is the really clever part. Rate-In leverages information theory to figure this out.
Okay, information theory, talking bits and bytes and all that.
Sort of. It uses this concept called mutual information to measure how much information is lost at each layer of the neural network because of those dropped out neurons. The goal is to keep this information loss below a certain threshold ensuring that enough information gets through for an accurate prediction while still introducing enough variability for good uncertainty estimation.
So it's a bit of a balancing act.
It is, and the beauty of Radin is that it does all of this during inference, meaning while the AI is actually making predictions, it doesn't need any extra training data or special labels. It just works.
That's pretty impressive.
Yeah.
So it sounds like Radin has the potential to be a real game changer in the world of AI. But did it actually live up to the hype? Did it actually improve uncertainty estimation in practice?
That's what we'll be diving into next.
Hmm.
The researchers put Radin to the test on a variety of tasks, from synthetic data to medical images, and the results were pretty remarkable.
Okay, I'm all ears. Let's talk about those results and what they mean for the future of AI.
Welcome back to Talk Tensors. Last time we left off with this big question, did Radin actually deliver the goods when it comes to improving uncertainty estimation?
Right, we talked about the why and the how, how traditional AI models can be overconfident and how Radin uses these dynamic dropout rates and information theory to try to address that.
Right, but the real test is, does it work in practice?
Exactly, so spill the beans. What did the researchers find?
Well, they put Radin through its paces on a whole bunch of different tasks, and the results were really impressive. Like, they started with synthetic data, where you can precisely control the level of uncertainty.
Kind of a controlled environment to see if it works the way it should.
Exactly. And Radin consistently outperformed the traditional methods with those fixed dropout rates we talked about.
Okay, so it passed the theoretical test, but what about the real world? How did it do with real data?
That's where it gets really interesting. They applied Radin to a couple of different medical imaging tasks, classifying images from the MetaMist dataset and then segmenting prostate MRI and liver CT scans.
And those are tasks where uncertainty estimation is like mission critical, right?
Absolutely. A misdiagnosis or an inaccurate segmentation could have serious consequences.
For sure.
So it was really encouraging to see that Radin not only improved uncertainty estimation in these tasks, but in some cases it actually boosted the overall accuracy of the models.
Hold on, it made the AI more certain and more accurate. How is that even possible?
Yeah, it seems counterintuitive, right? But think about it this way, by being more selective about which neurons it drops out. Radin is basically helping the AI focus its attention on the most informative parts of the input.
So it's not just randomly throwing away information.
Nope. It's more like the AI is saying, okay, I'm going to ignore these parts because I'm already pretty sure about them, and I'm going to really focus my energy on these other parts where I need more info.
That's pretty clever, making the AI more efficient and effective.
It is. And the results back it up. The paper has some graphs comparing Radin to the traditional fixed dropout methods, and you can really see how Radin pulls ahead, especially as the dropout rate increases.
So higher dropout rates generally lead to more uncertainty, but Radin is better at handling that uncertainty than the fixed dropout approaches.
Exactly. It's like Radin is a more skilled tightrope walker,
Right.
able to maintain balance even when the rope gets really wobbly.
Love that analogy.
Yeah.
Okay, so it seems like we've established that Radin works, it improves uncertainty estimation, and can even make the AI more accurate overall. But I'm curious, what kind of impact do you think this could have on the field of AI as a whole?
That's a great question. I think Radin is a significant step towards making AI more trustworthy and reliable. It's moving us away from that black box mentality and towards a more transparent and accountable approach to developing AI.
Yeah, because if we want to use AI in these critical domains like healthcare or finance or transportation, we really need to be able to trust its predictions and understand its limitations.
Absolutely. And Radin gives us a way to do that. It's like giving the AI a voice to say, hey, I'm not perfect, but I can tell you where I'm most likely to make mistakes.
And that's super valuable information, especially for the people who are relying on those AI systems to make important decisions.
For sure. I think this research could have a ripple effect throughout the entire AI community, encouraging more researchers to focus on this whole area of uncertainty estimation and developing new methods for making AI more transparent and accountable.
So it's not just about race in itself, it's about the bigger picture of making AI more reliable and trustworthy.
Exactly. It's about shifting the focus from just accuracy to building AI systems that are more aligned with human values.
Okay, so we've talked about the practical benefits of Radin, but I want to zoom out a bit. What does this research tell us about the evolution of AI in general? Like, where do you see this all leading?
That's a fascinating question. I think Radin is part of a larger trend in AI research. This move away from just focusing on raw accuracy and towards developing AI systems that are more human-like, especially in their ability to reason about uncertainty and explain their decisions.
So it's not just about making AI smarter, it's about making it more compatible with how humans think and work.
Exactly, and that's really important if we want to build AI systems that can truly collaborate with humans, not just replace them.
Makes sense. Humans are inherently uncertain beings. We make mistakes, we change our minds, we're always learning and adapting.
Right, and if we want AI to be a true partner in our endeavors, it needs to be able to handle that uncertainty, not just sweep it under the rug.
Okay, so this all leads to a really interesting question. If AI becomes better at recognizing and expressing its own uncertainty, could we actually use that to our advantage?
Ooh, now you're talking. That's where things start to get really exciting.
Right. It's time for novel notions, where we get to let our imaginations run wild and explore all the crazy possibilities that this research could unlock.
Always up for a good thought experiment. What kind of crazy ideas have you come up with?
All right, so imagine an AI that's trained not just to make predictions, but to actively seek out information that reduces its own uncertainty.
So instead of just passively receiving data, it's out there exploring, asking questions, conducting experiments, trying to fill in the gaps in its knowledge.
Exactly. And Radin would be the perfect guide for that exploration. The AI would focus its attention on the areas where it's most uncertain, gathering data and refining its model until it reaches a certain level of confidence.
I love it. We could call it curiosity-driven AI.
That's perfect. Think about the possibilities: AI scientists designing and conducting their own experiments, accelerating breakthroughs in medicine materials, science, even physics.
Or AI explorers venturing into uncharted territories, the depths of the ocean, the vastness of space, all driven by a thirst for knowledge and guided by their own uncertainty.
This is blowing my mind. It's like a whole new paradigm for AI, where uncertainty isn't a weakness, but a driving force for discovery and progress.
It really is exciting, isn't it? Of course, there are a lot of challenges we'd have to overcome before we could realize that vision, but I think it's definitely worth exploring.
For sure, and who knows, maybe someone listening to this will be inspired to take that idea and run with it.
I wouldn't be surprised at all. Sometimes all it takes is a little spark of imagination to ignite a scientific revolution.
Well said. Now, we've been talking about all the awesome things Radin could enable, but I'm also curious, are there any potential downsides we should be aware of? Could this whole focus on uncertainty lead us down some unexpected paths?
That is a really important question, and it's one we'll explore in more depth next time when we wrap up our deep dive into Radin and what it means for the future of AI.
All right, stay tuned for part 3, where we'll venture into some uncharted territory and consider the potential challenges and ethical considerations of this whole idea of uncertainty-aware AI.
See you next time on Talk Tensors.
Welcome back to Talk Tensors. For the final part of our deep dive into Radin and this whole fascinating world of uncertainty in AI.
Yeah, it's been quite a journey. We've gone from the nitty-gritty of how this Radin thing actually works all the way to, some pretty mind-blowing possibilities for this curiosity-driven AI idea.
Right. I'm still kind of geeking out about that novel notion segment, but like we hinted at last time, it's not all sunshine and roses. There are definitely some potential downsides to think about when we start talking about AI that's more aware of its own limitations.
For sure, any powerful tool can be misused, and AI is no exception. As we move towards this idea of AI as a collaborator and an explorer, we need to be super careful about how we guide its development and how we actually use it out in the real world.
Okay, so let's get down to brass tacks here. What are some of the things that worry you about this new era of uncertainty-aware AI?
Well, one concern that always comes up with any AI system is the issue of unintended consequences. We can train these systems to optimize for certain goals, but it's really hard to predict all the different ways that those goals might actually play out in a complex real-world environment.
So it's like giving the AI a map, but not telling it about all the potential detours and roadblocks it might encounter along the way.
Yeah, that's a good way to put it. And when you add uncertainty into the mix, things can get even more unpredictable. Like an AI that's uncertain about its environment might behave in ways that seem totally irrational or even dangerous to us humans.
Okay, can you give me a concrete example?
Sure, imagine an autonomous vehicle that's trying to navigate a busy intersection. The AI might be uncertain about the intentions of the other drivers, which could lead to some overly cautious or even erratic behavior.
We don't want an AI that's so uncertain that it ends up causing accidents.
Exactly. So it's crucial to develop these really robust safety mechanisms and testing procedures to make sure that any uncertainty-aware AI systems behave predictably and reliably when they're out there in the real world.
Okay, unintended consequences, got it. What else should we be thinking about?
Another big challenge is making sure that these uncertainty-aware AI systems stay understandable to us humans. Like if an AI tells us it's uncertain about something, we need to be able to understand why it's uncertain.
Yeah, otherwise, how can we trust its judgment or make informed decisions based on what it's telling us?
Precisely. So explainability is key here. We need to develop methods for making the AI's thought process more transparent so we can really understand how it arrived at a particular level of uncertainty.
So it's not enough for the AI to just say,
It
I'm
is.
not sure. It needs to be able to say, I'm not sure because of X, Y, and Z.
Exactly. And those explanations need to be something that a human can actually understand, even if they're not an AI expert. It's a tough challenge, but I think it's absolutely essential if we want to build trust and ensure that these systems are being used responsibly.
All right, so unintended consequences, explainability. Those are two big ones. Anything else we should add to the list?
Hmm. Well, there's also the tricky question of how do we handle uncertainty in those situations where human lives are actually on the line? Like, imagine an AI system that's helping doctors diagnose and treat patients. What happens if the AI says, hey, I'm really uncertain about this particular diagnosis or treatment recommendation?
Yeah, that's a tough one. We obviously want to leverage the power of AI to help us make better decisions, but we also don't want to just blindly follow its lead, especially if it's expressing a lot of uncertainty.
Right? It's a delicate balance. So
Yeah.
we need to develop these clear protocols for how human decision makers, like those doctors, should incorporate the AI's uncertainty estimates into their own decision-making process.
Yeah, it's almost like we need a whole new set of ethical guidelines for this age of uncertainty-aware AI.
I think you're absolutely right. As AI becomes more and more sophisticated and more integrated into our lives, we need to evolve our ethical frameworks to keep pace. It's not just about preventing AI from doing harm, but also making sure that it's used in a way that aligns with our values and promotes human well-being.
This has been a really thought-provoking conversation.
Yes.
We've explored the exciting potential of rate-in and uncertainty-aware AI, but we've also uncovered some really thorny questions about unintended consequences, explainability, and how we make ethical decisions in this new landscape.
It's a lot to grapple with for sure, but I think these are exactly the kinds of discussions we need to be having right now. The future of AI is being shaped as we speak, and it's up to all of us to make sure it's a future we can all be proud of.
Couldn't have said it better myself. And on that note, I think it's time to wrap up this episode of Talk Tensors. We've covered a ton of ground, from the technical details of how rate-in works to the philosophical implications of building AI that understands its own limitations. We hope you've enjoyed the journey and that you'll join us again next time for another deep dive into the ever-evolving world of machine learning.
Thanks for listening, everyone, and remember, stay curious.